This is the ENIAC, the world's first digital computer. At 30 tons, it filled an entire room at the University of Pennsylvania, where a section of it is on display today. This small electronic plaque can tell you more about it. It's arguably 2 billion times faster than the ENIAC. That may sound like an impressive leap forward in computing, and it absolutely is, but Nader Engheta is forging a path toward what may turn out to be an even greater one.
I was born and raised in Iran. As a child, I was always interested and curious to find out how things work. When I was in high school, one of my older brothers was working on a battery-operated transistor radio. And I asked him, how does this gadget work without being connected to anything?
The radio waves his brother spoke of would capture Engheta's imagination. They make up a tiny part of an entire spectrum of which only a fraction is visible: light. Engheta came to the US in 1978 from the University of Tehran, determined to engineer devices powered not by electricity, but by light waves.
In order to achieve a new and interesting functionality, we need to manipulate and control waves. And for that, we need materials.
Light tends to travel in a straight line. Engineering light-powered devices requires materials that can alter the direction of light, the way wires and circuits guide the path of electricity. Engheta became a pioneer in engineering metamaterials. These don't occur naturally, but can be manipulated to guide packets of light, very loosely speaking, the way bumpers in a pinball machine guide the direction of a ball.
You can imagine arranging bumpers so that photons bounce around an obstacle, which Engheta did in 2005, inventing a cloaking device that could shield objects from certain forms of light and interference. He later used the same principles to create a type of nanoscale circuitry, the same components you might find inside modern electronics, but infinitely smaller, powered not by electricity, but light.
One of the interesting aspects of scientific process is serendipity. Often it happens when you're working on a project, you may discover something that you have not been looking for, and that will actually put you in a very interesting direction.
With a burgeoning toolbox of light-manipulating inventions at hand, Engheta wondered, what if he could harness his know-how and build a device that could supersede one of the most disruptive innovations in modern times?
This is a metamaterial photonic processor, scaled up for prototyping purposes. In practice, it would occupy only a minuscule region on a computer chip, one of thousands like it. A pattern of light waves enters the metamaterial maze, structures fine-tuned to solve a given equation. The solution comes almost instantly, entirely at the speed of light.
A paradigm-shifting computing platform that can handle large amounts of data using very high speed, small volume, and low power, and parallel processing will be crucially needed. And I believe this computing platform can address that need.
Computers so fast, small, and efficient would be bound only by the size of the interface needed for us to run them, sparking another evolution in computing that could relegate the fastest devices we have today to the history books.
I love light. I love waves. When you are in love and you're passionate about the topics that you're working on, and you ask curiosity-driven questions like what if question, why not question. When you're passionate and you're in love with the subject, you'll do great. And be courageous in doing new things.